Quiz Prep, Chapter 4.2. Hello, here we are at Chapter 4.2 Quiz Prep. So this is a sequel to 4.1. So I'll remind you what happened at 4.1. It was very exciting. What we had was we had 5 U.S. colleges. Ta-da. We had 5 XY pairs then. There were salaries for male professors, average 1,000 per year. And salaries for female professors. So each college had its own X and its own Y, right? And then we asked a question. We said, does it matter what males are paid for what females are paid? Like if males are paid more, are females paid more? Males are paid more, are females paid less? What is that? So what we dealt with was calculating R, okay? And we had to calculate all these ingredients to R. Well, guess what? In 4.2, because this is a sequel, they remind you of this, and here's the information. And in fact, we even did a scatter plot. And why do we do that? Because we wanted to see the correlation. And we found out the 2 things you need to know about a correlation. First of all, was it positive or negative? Well, later we learned from R that it was positive, because R was positive. But we could see in the scatter plot before we got there that it was going up, like a little line. But it's not perfectly on the line, and that's kind of an issue. We'll talk about that. If it had been going down, it would have been negative. So we just diagnosed it as positive, and then we had to say whether it was weak or medium or strong. Well, looking at R, because R was 0.95, we could just say strong. That was our opinion. But even just looking at the scatter plot, it looked pretty strong. And by strong, I mean, imagine there was like a perfect line here. How far off are they from the perfect line? If they were all over the place, I'd say, well, that's weak. If they were just kind of off, I'd say, well, that's medium. And this is almost on the line, so I say strong. Okay? Now, the reason I'm saying all that is because in 4.2, I've been saying line, 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 line. Well, wouldn't you kind of want to make a line, right? We've already made R. Why not make an equation that explains these dots? In other words, maybe, since we have this X up here, we could make an equation of these X's and Y's so that if we had like another college here, F, we could put an X in and then calculate the Y and figure out what an estimate would be of what women would make, which would be kind of important because like I'm a woman, right? And so if I had an average of what male professors make at some college, I could maybe then predict what I would make, which would matter because then I probably wouldn't want to go there if it's too low. So that's why they even make these equations, is so you can predict things. So that's what we're going to do, is we're going to move forward from just having R to making a linear equation. All right? And here's me again. I'm not even getting to quiz prep yet because I just want to remind you what we're going for here. Okay, so I just put that scatter plot up there. But what I wanted you to do is have sort of a flashback of algebra. Okay, so remember in algebra, you could have like XY pairs. Here, XY. You'd have these pairs, but they were always perfectly on a line, right? Like if X was 1 and Y was 2, you'd go over 1 for X and 2 for Y, and you'd put this dot. And it never went off the line like it does here. So if X was 2, then Y would be 4. 2, and whoops, I didn't mean that. I was just trying to go up here, and this would be 4. See, 2. See, and it would be perfectly on the line forever. And the reason why you even graph that, you probably don't even remember graphing all that stuff, but maybe you remember. But the reason why they started you with that is they wanted you to realize that y was a function of x. In other words, you could plug in an x into an equation and get the y because the y was perfectly predictable. And so then they'd say, well, what's the equation from the line? And they'd say, here's like the generic equation. So y equals, now I'm going to change the color, right? The color is B. Then I'm going to go x plus, then I'm going to go back to this color A. Now, why did I make that different colors? Because it's boring otherwise. Well, that's true. But I actually made it different colors because one thing that's sometimes confusing about this is the goal is to keep the red part. The red part is still going to be there in our answer, okay? It's what we want to do is replace this B and this A with real numbers, and that's what makes the linear equation. Why are we doing that? Because remember we want to make a thing where if we plug in an x, we get a y out the other side. So all we're trying to do is figure out what b is, which is going to be the slope of the line, right? So, when we had algebra, what was this? This is rise. This is probably so old-fashioned. Over run. That's what we used to call that. So we'd say rise over run. You don't have to know this for this. I was just trying to remind you that we'd have this slope here, and that's what would go in for b. In case you notice, this is not a line over here. So the equation for b, for this least squares line, like we're going to make an equation for the line that's like the closest vertically to each of these dots, which I don't know where that is. I just drew that thing. That's probably totally wrong. So don't draw a thing and just try to do like an algebra. Instead, use this equation we're going to use here and get b. And that'll be horrible, but we'll get through it. It'll be like R. Only it's a little easier than R because we use the same ingredients as R. But once we get B, then we have this little trick for back calculating A. And once we get B and A, then we have our equation, and you put that down and get points for it if you're taking the quiz. And then also the last step is going to be coming up with your own X and putting it in and predicting a Y. Okay, so that's the big picture of what we're doing. I just had to say that before we moved on. Hi there, so here we are. I transferred some important information to the slide. So remember we were going after the b and the a in the y equals bx plus a equation. So here is the equation for b. We're going to have to go through that, right? But you'll see I transfer this information over here. These are the ingredients for b, so it's not going to be so bad. We already have those. Also, I didn't really go into this before, but here is the equation for a, which requires b. That's why we have to start with b. But notice what else it requires. It requires this y bar and this x bar. So that's my little preamble to say why question 1 is compute x bar and compute y bar, right? Like 1a and 1b. So we all know how to make a mean. You add up all of them and divide by how many there are. But I just want to remind you there's actually a fancy way of saying this. So this is the formula. X bar equals sum of x, right? All the x's divided by n. And of course y bar equals sum of y divided by n. And we can do that with the things that I put over here on the slide. So x bar is going to equal, notice that the sum of x's up there is 167.3 divided by n, 5 is our n. And I did that already, so that's 33.5. Okay. And then let's do y bar. Oh, I'm so sick of that color. Let's do pretty blue. Y bar equals, and we know what sum of y is, it's up there, 166.7 divided by 5 equals 33.3. Okay, so that's what we would put in here. I'd put this one in here. I don't think I'm a very good writer, so you know what goes where. And then we'll be done with question 1, and you know what's coming up in question 2, so we'll do that in a moment. Hi there, we're back on the actual quiz prep here. I just wanted to let you know where we are. We just filled in question 1, and now we're going to do question 2. We're going to compute the b in this equation, compute the a, and then we're going to write out that least squares line. So here we go. Okay, here we are. You'll notice that I've got these formulas here. I also added over here the information that we just figured out about x bar and y bar. So now we're all ready to calculate. So let's start with trying to calculate b. So you know how I think about things, right? I was just talking about r this way. We have this numerator and this denominator. You know, the numerator's on top, denominator's on the bottom. The numerator has these two terms, and you have to do them out because they're multiplication, and then you minus them. Then the denominator, at least we don't have any square roots. That was really annoying. And then the denominator down here, you've got two terms here, and you have to do those out and then minus them, and then you end up with a fraction, and then you deal with that. So we're going to take it's not the same as r. You know, b looks a lot like r, but it's not the same. So we're going to just take the same approach. So this first one, I'm just going to rewrite it. I don't know why it makes my life happy. Okay, this is just the first term in the numerator, and let's just figure it out. Maybe we'll change colors here. So that's going to be 5, right? And then sum of x, y, ooh, that's going to be times our little star here. 5,591.2. Okay. So let's just put parentheses around it. That makes it nice and cozy. Okay, so then let's go back to red. So that whole thing minus, and then we've got sum of x times sum of y, right? Sum of x times sum of y. So what is that in real life? Is minus, and then we already know what sum of x is, don't we? Yeah, it's 167.3. Whoops, I didn't mean to do that. We're going to do a little star here. And sum of y, what's that? 166.7. Okay. So if we work that one out, what we will get, or I did this, for this one, I'll change colors here. I got 2, 7, 9, 5, 6, and then minus, and then I got 2, 7, 8, 8, 8.9. Okay, but if you do that whole thing, the whole thing, you know, this equals, you can just put an equals there, and you get 67.1. How about that? Okay, so we're going to do, so this top half, I'll just do like this, is 67.1. Then let's just erase some of this because that's just the top half of the B, right? We still haven't even gotten the bottom half. So let me clean up here. Oh, I'm already exhausted. I don't even know about you. Okay, so let's go back. Let's get started on the denominator. And so that's n square root of x squared with no parentheses in it, which is nice because we have that on the slide, right? So that's going to be, oh, and minus, we might as well do this, parentheses, sum of x squared, okay? Remember our trick. We sum the x first and then square. Okay. So what does that mean with our data? Well, we got our big old friend, the 5. And then sum of x squared is on the slide. That's 5619.4. And then you're going to minus that. And then we remember sum of x. Well, I can even do this for you. Sum of x is 167.3, and then we're really going to have to times it by itself. So 7.3. Okay. And let's see here. I did that. Didn't I do that? Yeah. So I got 28097 minus 27989.3, and when it was all said and done, I got 107.7, which basically goes up here, because then now we've basically boiled this down to that. Now let's get rid of all this. This is the final, and this is just B. I mean, we still haven't even done A. Let's clean this up a little bit. Okay, so I don't know what just happened. All right, so let's see here. So when we do this whole thing, we'll do equals. Oops, equals. What do you get? You get 0.6. So that's the answer to B. Is B equals 0.6. Now, what we also remember is that we calculated these earlier, and now that we have B, I'm kind of moving on to A, right? Because here, if you just look at this, you know, we've got A equals y bar minus bx bar, and that was our barrier before. Now we can just say A equals whatever y bar is, what was it, 33.3 minus, and then we got to do this, 0.6, that's the B we just got, times that x bar up there, 33.5, right? And let's see here. If you go through all of that, well, um, basically what you end up having to do is algebra, right? So you end up with this 33.3 equals 20.1 plus a, right? And then if you remove this 20.1, you end up, I'm just kind of showing you the intermediary steps. You end up with, no matter how you do it, you end up with a, if you do it right, you end up with a equals 13.2. Okay? So what I'm going to do is erase this part here because I just want to remind you, remember when I wrote that equation out and I had the different colors because I was saying, some of it you fill in and some of you don't. So I'm going to go back to that equation. So I originally had written like y, well, we'll say y hat because it's an estimate equals, it's not an estimate in algebra, but in stats it is equals, we said bx, whoops, I didn't mean to make the x like that, bx plus a. Remember I said we're going to have to fill in the purple part. Well, now what we're going to fill that in with is, now I'm going to write the whole thing. Let's write in green. Y hat equals, here's b, 0.6x plus, and then here's a 13.2. So this expresses that line that's going to be the perfect least squares line that goes through that data about the men and women professors. Okay, so that's the answer to question 2. All right, so once you really get into this and you realize you can compute this B and this A for like really any XY set of XY pairs, you start to wonder, maybe I can predict stuff. Maybe I can make these lines and predict things like stock, like people thought of that. The problem is, just because you can make a line doesn't mean it's a good line, right? So they have this thing called the coefficient of determination. That's what we're going to calculate next. And that coefficient of determination helps us decide if we really want to use that linear prediction or not. So that's what we're going to do next. So after you calculate your least squares line, and you've already got R, you already got all this stuff, to check yourself, you calculate the coefficient of determination, which I'm going to just say is CD because I don't feel like writing all that out. So what is the formula for that? Well, it's super fun, because it's like this huge word or phrase, and it's just R. Remember R over here, our old friend R? It's just R squared, right? So you're like, okay, well, that wasn't very hard. So literally you take in this case, 0.95 times 0.95, and then remember the coefficient of variation from chapter 3? Well, the coefficient of determination is like the coefficient of variation in that you have to turn it into a percent. We have all this etiquette in science, statistics, where certain things have to be a percent, certain things have to be not a percent, whatever. But anyway, they like it as a percent. So if you do that, you're going to get 90%, right? So again, this feels very R-like in the sense that what does 90% have been made? Well, the official party line, what you're supposed to say is that 90% of the variation in Y is explained by X, which kind of suggests that X matters. It depends on what X is, what Y is going to be. If this was really low, like maybe 10%, then you would say, well, 10% of the variation in Y is explained by X, and that means it's like that I Love Lucy, there's a lot more explaining to do, right? Obviously that X is not really doing a very good job of explaining the Y, so you're probably missing some other variables that might explain the Y. So but as it turns out, yucky, we don't have a bad CD, we have an awesome CD. We have this 90%. So what is that telling us? It's telling us that we could actually use this prediction line. We could actually use it. Like if I was shopping for a job and I knew, the average male salaries, I could actually put them in there, into the equation and predict what, a good estimate of what my salary would be. And I really should do it because this coefficient of determination is so high. Okay, getting back to actually filling out quiz prep, let's go to 4A. What percentage of variation is explained by the model? Well, that's a secret way of asking what the coefficient of determination is, and we said it was 90%, and that's pretty darn good, so we'll put that there. What percentage of the variation is unexplained by the model? Well, it's the rest. It's 10%. So there's not much left to be explained. That's a pretty good model. So referring to your least squares line equation, and it's matching R and coefficient of determination, say whether or not you should use this model for prediction and say why. Well, remember we were looking for a high number here and we got one. So we say, yeah, we want to use it. So these nosies, we're not going to say no, we're going to say yeah. But then there's two yeahs, so which yeah do we want? C says, yes, you should use it for prediction because the coefficient of determination is high enough. That sounds about right. D says, yes, you should use it for prediction because the coefficient of determination is low enough, which makes literally no sense. So the answer is C. Okay, finally we're at the end here. We're at question 6. So now you'll see what I put up here. I put the question, but I also put our equation that we created. Why? It's finally time for prediction. So imagine a college pays male professors on average $40,000 per year, or X equals 40. So what is the predicted salary for females? So what do you think we're going to do? We're going to do 0.6 times whatever this X is, because that's why we need to leave the X in the equation, right? It's because we need to be able to put something in. So 40 plus 13.2. And that's actually a pretty simple equation. If you do that, you're going to get 37.2. So if somebody came to me and said, hey, my college, they were a guy, and they said the average that men make here is 40,000 a year, I would say, well, according to my pretty good equation with a nice high CD, coefficient of determination, I would then be making less than you. So I'm not going to go work there. All right, so good job. We made it through quiz prep for 4.2. So just to remind you, what we did is the goal was to get that least squares line out. We had to do x bar and y bar to do it. We did this huge equation for b, and then we back calculated a, and then we got our linear equation. Then we asked whether it was any good by calculating the coefficient of determination. We said it was hot, 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 hot. And then we went to use it to predict our potential salary and maybe not waste our time applying somewhere. Okay, so great job. And now you're all ready. Good luck on Chapter 4.2 quiz.